Now students, let us see the new topic. Here we are having force due to magnetic field. Okay, as the name suggests, you know that current here is making magnetic field. Yes, so the current is responsible for developing a magnetic field, and that we have seen that production of the current is surrounded by the magnetic field around it. So what happens if we vice versa this thing? Okay, in presence of magnetic field, can we develop current also? So it would be very beneficial for us then. So here is the force due to magnetic field. First of all, you know that current is producing magnetic field, and here in later on terms we are going to read that magnetic field is also producing a current. But here what is happening, that magnetic field around it, do we feel force? Yes, of course, like here we are having a bar magnet, north and south pole, and you know that when we put a nail in between in nearby area of this magnet, so due to magnetic field around it, it will get attract towards it. It will sequentially get attached to it like this. Okay, that is fine. So we can say here that this nail is feeling a force. So there is a force that is exerted on this nail, and this nail now get attracted towards the magnet. Yes, okay. Now we are just talking here about current also. So because this is magnetic effect of current, so here the magnetic field that is developed is due to current also. And if we are supposingly put any kind of magnet in nearby, so will be it affecting? Okay, let us see it with example. First of all, let us see what is this. So current carrying wire produce a magnetic field. Now this magnetic field exerts a force on the conductor. So this is the same thing that this bar magnet is doing right now. But here in this case now we are taking a current carrying conductor. A current carrying conductor is having an iron nail, and now this iron nail can attract this towards this current carrying conductor because it is developing a magnetic field around it. Okay, so here the experiment that we can do is like this. Supposingly you know that here is a circuit, that is a full circuit here, and that is attached to this rod. Okay, so now this rod is going, AB rod is going to have a electric current sooner or later. Okay, so now as you can see, AB is getting a electricity, and that is a motion of electrons. What is electricity? Electricity is nothing but a motion of electrons. Okay, so that is clear now that electrons are moving in this rod right now, and these electrons are feeling force. Why? Now, because if this rod is kept in between a magnet, because here this rod is generating a magnetic field itself, and that magnetic field get affected with this original magnet. This magnet is also originating a magnetic field itself, and this rod, because of the electric current that is passing through it, it is also generating its own magnetic field. Now magnet and magnet together will provide certain force on each other, right? Like if I have this magnet, bar magnet, simple bar magnet, and one more bar magnet is here. So whether irrespective, like if we see the faces of these magnets, like north and north are here, so they are alike, so they will repel each other accordingly. So we can say that this particular magnet is having its own magnetic field, this particular magnet is having its own magnetic field, and these, due to the clashes of these magnetic fields, they both will do certain force, will provide certain force on each other. That is the same thing that we have seen here. This rod is having a force around it due to what? Due to the magnetic field it is producing, and that magnetic field is clashes with this bar magnetic field. Okay, so this was the condition, this was the activity, and here we are having a point on it, like because of the interaction between magnetic field produced by the current carrying conductor and the external magnetic field. So here the horseshoe magnet is the external magnetic field, and the magnet that is magnetic field that is produced by the wire itself. So we can say that it is also having a magnet. So this is the best example, I guess, to think about that yes, magnetic fields clashes with each other and accordingly they will act. So we can say that magnetic field is also producing a force. Okay, because they both are feeling a force on each other. So force is here. Now let's suppose we are replacing this one magnet with this current carrying conductor, and because due to the current, magnetic field also develop around the rod, so it will again forcefully attract or repel to each other. Okay, so this is what this force due to magnetic current, magnetic effect of the current is getting the force. So this is what this topic is talk about. So on what thing this kind of force is depend. Okay, let us see that this current carrying conductor is having a current and the magnetic field is also generated here. So what are the factors? And in this activity what we have taken? We have taken one current carrying conductor in which the current is flowing, and we have taken this external magnet. So here we are having again two things. So what is the factor on which this kind of force is depending? कि force छोटा होगा, थोड़ा होगा या बहुत ज़्यादा होगा, वो किस पे depend होगा? So here are the factors. The direction of the force on the conductor depends upon, and direction also, direction of the current and the direction of magnetic field. So by this thing, dear all, you can see direction of current, whether it is moving in bottom to top or top to bottom. It depends on it, because direction of current is only the thing that we have seen with the help of right hand thumb rule. That here in this case, when we are rolling it like this, so fingers are showing the magnetic field direction. So this is the direction of magnetic field when the current is going from bottom to top, that is in the anti-clockwise direction. And when this is going to be like this will be a clockwise direction when the current is flowing from top to bottom. So direction is depending the magnetic field around it, magnetic field's direction. And also if we are taking the external magnetic field here, okay, by putting a horseshoe magnet here, so north and south. Okay, now north is here and south is here, so what we are having? A magnetic field like this. So this magnetic field's direction and this magnetic field's direction will going to produce certain force that depends on these two directions. So here is the topic that we can say here, the direction of the force depends on the direction of current and direction of magnetic field. So students, as we have seen that the direction of the current and the force that is developed by the current's magnetic field and the external magnetic fields is depending and resulting into the force. So here is when is force acting on the current carrying wire is highest. Okay, so if we want to find out whether the current carrying conductor, like in the previous experiment that we have done, what we have done, we just put a rod here in the place of the magnetic field like this, and so this is a current carrying conductor, so it is having its own current and due to which it is containing a magnetic field around it like this, and this magnetic field due to the clash with this normal magnets, so it will get a force, it will feel a force here. So we have seen the direction of this current, like it is positive and negative, positive terminal to negative terminal. So current's direction and magnetic field's direction, both the direction are depending on the force direction. So that is force direction that we gonna calculate. But the thing is, when this is going to be maximum, if you want to know that the feel of the force is maximum, ki force sabse zyada kab lagega. Okay, so here for that we are having a condition that force acting on the current carrying wire is highest when the direction of the current is at 90 degree. Certainly this is true. Likewise, if a bar magnet is like this, let me tell you with the example like this. This is the north and this is south, and the wire here is perpendicular. Current carrying conductor is perpendicular to the magnetic field lines. The magnetic field lines here is going like this, north to south. You know that outside the magnet, it is always going from north to south. So here you can see that all the magnetic field lines are making 90° with this current carrying conductor. At this time, it is going to feel maximum force and it will deviate from its path maximum. So with the next diagram that I can show you is like this. See, here in the direction it is 90°, so it is going to feel maximum force at this time, and when it is slightly tilted, so it is feeling certain force but not maximum like in the above condition. Okay, there will be a certain force but not like the above example. And now in this condition, when it is already in the parallel to the magnetic field line, so we can see that here this current carrying conductor is not going to feel any kind of force, because now the magnetic field lines produced by this current carrying conductor is going to be simulate according to the magnetic field lines. अब ये जो करंट कैरिंग कंडक्टर है, इसकी जो मैग्नेटिक फील्ड लाइन है, ये इसके साथ सिंक्रोनाइज हो जाएगी. मैग्नेट, ये जो एक्सटर्नल मैग्नेट्स है, इनके साथ में सिंक्रोनाइज हो जाता है. सो अब फोर्स तो लगेगा ही नहीं, बिकॉज इट विल फील लाइक दैट ये भी मेरी ही मैग्नेटिक फील्ड लाइन है, दिस इज ऑल्सो माई मैग्नेटिक फील्ड लाइन. जब फोर्स कब फील होगा? जब दोनों में क्लैश होगा, तभी तो होगा ना फोर्स फील. अगर आप हवा के साथ में ही चल रहे हो, इधर विंड चल रही है और आप भी इसी के साथ में चल रहे हो, देन यू विल नॉट फील सर्टेन काइंड ऑफ फोर्स, लाइक ठीक है, यू कैन इजीली मूव ऑन. ओके, बट अगर विंड इसी डायरेक्शन में चल रही है एंड यू आर मूविंग इन अपोजिट डायरेक्शन टू इट, और यू आर ऑब्स्ट्रक्टिंग लाइक इट, यू आर प्रोटेक्टिंग इट, लाइक दिस विंड इज गोइंग नॉट टू बी forward like this in this way, so you are restricting the wind, then only you will feel a lot of force. So here is the same example in this case, that we can see that this current carrying conductor in the first example, here it is crossing, it is letting all the magnetic field lines. Let's suppose this my hand is the current carrying conductor and this is magnetic field lines. So all the field lines are now, because they are crossing the conductor like this, so we will feel like, yeah, it is a maximum force that is going to be felt at the moment when it is tilted slightly. So some of the magnetic field lines will easily pass on like this, and some will feel that here is a force. But when it is all parallel, so they all can go like this, so there is no obstruct there. So this is the example, and this is going to have a practical example, like here in motor, and you know that motor we use in various appliances at home. So this is by using this kind of electricity in between the magnet, so we can produce a force, and that force we can use for certain kind of work. So that is what motor do. So let us now move on with another topic and clarify this topic. I guess these examples are very well enough to understood this topic.